welcome to Ipsa Dixit, a podcast on legal scholarship. I'm your host, Brian L. Fry, Spears Gilbert Associate Professor of Law at the University of Kentucky College of Law. My guest is Athul K. Acharya, an Impact Litigation Associate at Braun, Hagee & Borden, LLP. We will discuss his article, Abstraction in Software Patents and How to Fix It, which is published in the John Marshall Review of Intellectual Property Law. So welcome to the podcast, Athul.
Thanks, Brian. Thanks for having me on.
Yeah, so I got to say, I was so happy to read the final version of this paper after reading the draft you sent me a while back, because A, I think it's really good, and B, I got to say, I really think it's really well done. I mean, it, like, in a weird way, it reads like beautiful code almost. It's like so perfect.
Thank you. I really appreciate that. And thank you for your comments on the draft. They actually really helped me sort of come up with the ending, and sort of flesh out the proposal that I had just sort of stuck on at the end in the draft that I sent you. So thanks for that.
My pleasure. Anytime. I'm always happy to offer comments, especially to junior scholars. So, Athul, I was thinking that for listeners those listeners out there who might not be that intimately familiar with patent doctrine, I'm sure there's a couple.
One or two.
I wonder if you could start by talking about patentable subject matter and the abstract ideas doctrine.
Sure.
Sort of what role does the abstract ideas doctrine play in patent eligibility?
Sure. And so just stop me if I forget sort of how much background people have, because obviously I practiced in this area for a long time. Patents are there's a statute, 35 USC 101, which says what can be patented, and it's really broad. It says any process, manufacture, machine, or composition of matter can be patented. And some courts have said that basically means anything under the sun made by man, something along those lines. But the Supreme Court actually, from almost the earliest days of the American patent system, has said that there are certain implicit exceptions to what can be patented. And those exceptions have sort of morphed and mutated over time. But they basically encompass the modern formulation is pretty good, I think. It's laws of nature, natural phenomena, and abstract ideas. So laws of nature is a pretty sort of self-defining category, like E equals MC squared, or the law of gravity, or pick a law of nature that's not patentable. Products of nature also, natural phenomena these days are also relatively self-defining, although there's more. There was one big case on that not long ago involving gene patenting. And then abstract ideas is the third category, and as befitting a category called abstract ideas, it is itself quite abstract. It's not very clear what an abstract idea is. That lack of clarity is exacerbated by the fact that the Supreme Court sort of was active in the area for a while, and then the Federal Circuit was created, and Supreme Court just sort of retreated from the field, and the Federal Circuit purported to follow Supreme Court precedents, as all circuit courts must, but was actually quite hostile to them, and so they sort of munged up the area of the law quite a bit. And then recently the Supreme Court has re-arrived in force, and it's just thrown the area of law into disarray. Although I do think, I opened the paper with sort of a compilation of some of the not so nice things people have said about the abstract ideas doctrine. I do think that in recent years, so Alice, the sort of seminal Supreme Court case in the area, was 2014. It's now only 2019. 5 years is not that long in terms of doctrinal development. And I do think that the doctrine has sort of started to settle down. Although even as I say that, last year there was a Federal Circuit case that sort of kicked up the dirt again and made it much more of a murky field. So we'll see. There may be more room for the Supreme Court to tamp down the doctrine. But yeah, so the abstract ideas doctrine has two parts. The one part is whether so a patent consists of a lot of different parts, but the part that sort of sets out the metes and bounds of what you have a monopoly on is the end, the claims part. And I give some examples of what claims look like in the paper. And so the abstract ideas doctrine says first, is your claim directed to an abstract idea? And this is kind of like a high pass filter. So if your claim is directed to like something physical, something like an LED screen or a dump truck or a screwdriver, that's obviously not an abstract idea. So you're in the clear. Even as I say that, there was a Federal Circuit case in the last week or so that declared, can't remember what it is, but some like physical thing that you could hold in your hand declared it an abstract idea. And
what?
Yeah, I think it's one of those situations where you can hold the object in your hand, but the innovation was really in the software inside the thing. And I didn't read the case. I saw it and I was like, oh, okay, I'm very busy. I'll have to come back to this. This is going to require more than just like a 5-minute breeze through. But anyway, so in theory, at least, the first step of the doctrine is, are you describing something that's sort of tangible, or is there an abstract idea that you can sort of, like a pithy statement of the idea that a court will agree with? So, for example, the patent in Alice was directed to a two-word abstract idea, intermediated settlement. Having a middleman help you finalize a transaction, something along those lines. And then the second step is, okay, if your claim is directed to an abstract idea, is there anything more in the claim that transforms it? An inventive concept is the terminology in the doctrine that transforms it into a patent-eligible application of the idea. And I think this is really where sort of most of the meat of the doctrine is. And some of what I'm doing is trying to flesh out how that's been used. And what you see is in software cases, especially what the Federal Circuit is looking for is, are you offering an implementation of your idea? So it's fine to have an idea, right? Like all patents originate in ideas. But you can't just have the idea and then claim the idea and call it good. You have to claim an implementation of the idea. And so a lot of where Federal Circuit case law is converging is in looking for that and looking for the implementation as opposed to the idea itself. So that's sort of the basic framework of the doctrine. And then there are some genres of patent claim that are often found ineligible, and they sort of feature heavily in the paper. The most common genre is the do it on a computer claim, which was really popular for a while there because the patent office was just letting a lot of them through, where basically you take some long-standing business method often, or just something that people have done, and you say, all right, do that, but do it on a computer. And I think that was Alice. That was definitely Alice. Bilski was an earlier case which had that in some of the what are called dependent claims. You can sort of see how in the 80s, doing something like accounting on a computer, you might figure out a way to do that and think, wow, I've really invented something neat here. But if you don't describe how you did it, that doesn't pass the eligibility filter. It's not enough to just say do it on a computer. That's one genre. And then the other genre that you see a lot of, which is sort of related, is claims that just state the result. And so this is what I was talking about earlier, where if you just state the idea without an implementation, another way of saying the same thing, but sort of stated analogously, it's sort of another way to reach the same result of the doctrine, is if you just state the result without stating how you got to the result, without claiming how you got to the result, then that's also a common genre of ineligible claim.
Well, so your paper focuses specifically on how the abstract ideas doctrine ought to be conceptualized in relation to software patents. I wonder if you could talk a little bit about what a software patent is exactly, and how kind of significant software patents are in the patent ecosystem, and sort of why they present a sort of particular, potentially present a particular problem in relation to this kind of abstraction question.
Yeah, sure. So what is a software patent is actually there's academic debate on that, believe it or not. But in at least in the core of the category is claims on software. So claims on a software method of, and they're usually method claims, software method of doing something. I say they're usually method claims. They're often stated also as product claims, where the it's not product, but basically where the method is embodied on a physical medium. That's a piece of patent silliness, so to speak. Yeah, so it's a claim on software method, and the reason that software patents are sort of interesting and important, and need strong, I guess, abstract ideas doctrine, is because a lot of patents these days are software patents. I mean, almost every, something like a John Deere tractor has a lot of software in it. And in terms of what people are spending their time doing, they're spending their time on their phones, they're spending their time on their computers. Just a lot of what people interact with on a day-to-day basis is software. And so a lot of innovation happens in software. And then also a lot of rent-seeking happens in software patents. So, for example, in one study, and I mentioned this in the paper, in one study, something like 80% of patents challenged under ALICE, under the Abstract Ideas Doctrine, are software patents. They have a special tendency to be abstract, in large part, well, not in large part, but sort of, well, in part, because they, you're not describing a physical thing. You're describing a way of doing something, which sort of intrinsically is going to be one level of abstraction removed from a thing that does something.
Well, so what exactly does a software patent claim look like then? And like, why do you think software patent claims are sort of prone to abstractness, as it were, in a way that might be a problem in relation to eligibility?
Right. So this is sort of the meat of the paper. The reason software patent claims are prone to abstractness is there's twofold. One, the do it on a computer genre of claim. So, computer science, right? The science of software, it defines itself as the science of abstraction. The idea for this paper sort of came to me when I was thinking about why software patents are so often found abstract, and I was thinking about it, and I realized that at that point it was 12 years ago, or more, no more. Anyway, I realized that my very first computer science class, my very um, first time I stepped in a computer science classroom in law school and sat down, the first 10 minutes, within the first 10 minutes, the professor said, computer science is the science of abstraction. Um, and that's an important clue for why software patents are so often found abstract. And what he meant by that, and what the computer science literature means by that, is that um, a lot or all, depending on how you look at it, of what software does is deal with abstract representations or models of other things, often of real world entities. So if you're writing like a credit card processing software, right? You're not dealing with the physical credit card. You're dealing with an abstract model of a credit card. If you're writing a word processing program, you're not dealing with a physical document. You're dealing with an abstract model of the document. And when I say abstract, what I mean is that you're removing details of the physical thing you're modeling that are not relevant to the problem you're solving. For example, with a credit card, like it's not like my Chase credit card is made out of metal. That is completely irrelevant to a model of a credit card for purposes of processing it. So they don't keep that detail. They don't retain that detail in the model. Or if you're looking at a word processing program, there's no physicality of paper and ink. Are you using like the fancy cream colored paper or some cheap newsprint type stuff? None of that is modeled in Microsoft Word. So when you claim a software method, you're not claiming like what the words of your claim are going to say something like, a system for processing credit cards, or a method for processing credit cards wherein the credit card is stored on a disk or something, right? Like you'll say something like that. The words of your claim refer to these abstract models. So your sort of your claim words are going to be the nouns are going to be abstractions. They're going to be one level removed from the physical things that they refer to, or one or more levels removed from the physical things that they refer to. And then sort of add to that the fact that claims are meant to abstract stuff away, even from physical inventions. If you invent a new car seat, unless it matters to the functioning of the car seat, you don't have to claim whether it's leather or cloth or polyester or whatever. Like you're claiming the aspects of the car seat that are relevant to why it's novel and non-obvious and so on. You don't claim every last detail of it. So just like software, claims involve a level of abstraction, and they should. You shouldn't have to claim every possible variation of your invention, and you just couldn't. There's just an infinity of them. So claims are abstractions, and then software is often an amalgamation of abstractions, and what you end up with is an abstraction of abstractions. I mean, it's sort of abstraction squared, and that's how you end up with these do it on a computer claims, is because you're just taking real world reference, and if there's innovation, the innovation is in the modeling, but most of the time these claims aren't claiming the modeling. They're just claiming the idea of doing the modeling, and performing and achieving some result that processing credit cards or something, and that is a recipe for abstraction, because so many details are lost along the way that you end up with just an abstract idea at the end of it. So that's one way, but it's not the entire story, because there are software innovations that actually don't model real-world entities at all. So like if you have a better compression algorithm, or if you have a better programming language, or even like the innovation of web pages, which they're documents, but they're not they don't model like physical documents. They're hyperlinked, and they can be infinitely long, and they don't have pages, and all these other things. So web pages, programming languages, these things, they're not modeling real world entities. They're sort of intrinsic to the computer itself. But so you might think that sort of invention is less likely to be abstract. And you're right. The doctrinal line here is the line between do it on a computer claims and claims that I'm sort of loosely quoting, actually improve the functioning of the computer. And when you're a newbie patent litigator, you read that and you go, what does that mean? And it usually means that that the innovation is in is in something that is intrinsic to the computer and not a model of a real world object or entity. But such claims, such innovations are also often found abstract, and this sort of goes to the more fundamental problem, which is that one way of reaching an abstract idea, I mentioned this already, is that if you just claim a result and not the implementation. And it turns out that when you program a computer to do something, you're only describing results. You're not manipulating the electrons or describing how to light up the right pixels to display an image on the screen. You're there's a lot of levels of abstraction you could be working in, but at any given level of abstraction, you're just telling the computer to do something. Even at the lowest, like most of the time, like the level at which most programmers program, they're using a library of functions, and they're literally just calling a function to put a picture up on the screen. But even if you're programming in assembly code, which is the lowest level of computer code, what you're issuing or what you're writing are instructions to do something, not doing the thing. So your instruction is add 2 registers. And you don't care how it's done. You don't care about the gates that are opening and closing. And that's not an accident. That's entirely intentional. The sort of one of the most basic aspirations in computer science is, you write something once, you run it anywhere. And what gets in the way of that is every computer has a different architecture. Even my HP and your Apple Mac are going to be quite different internally, even though they will run a lot of the same software. Yeah, it's intentional that programmers write code using instructions and without caring how it's done, so that the computer can just get done whatever it is the programmer wants to be done. And when the aspiration is working properly, that's how things work. But what that means for the claims on software is what you're claiming. The thing that you're claiming is itself a description of results. You're not claiming you're not claiming patent law's sort of archetypal subject matter, which is like mechanical or chemical inventions. You're not claiming a structure. You're claiming you have to claim results, because what the innovation is a description of results. And at every level, from the lowest level of machine language instructions to the code in which it's written, all there is a description of the results that should occur. And they at each lower level of abstraction, what you just see is more details about what results should occur, but it's always just in terms of results. So of course your claim is also going to claim results, and that's exactly what the doctrine forbids.
Well, so I mean, Athul, when I was reading your paper, I couldn't kind of shake the impression that on some level you're kind of ambivalent, maybe, about software patents being patent eligible in the first place, but you propose a sort of heuristic or model, as it were, for sort of distinguishing between valid and invalid software patents, or sort of maybe even like a policy basis for distinguishing between valid and invalid software patents. Well, why is that? Like, what, if any, are your concerns about the eligibility, and how do you think we should go about distinguishing between eligible and ineligible software patents?
Sure. Yeah. So yes, I am skeptical. I purposely don't like my, there's a billion, not literally, but literally a billion papers out there explaining why software shouldn't be patentable. I don't think I have anything to add to that literature. It is saturated. The basic reasons are, IP rights, at least under the American conception, are typically justified on economic terms about whether they will generate more innovation than they'll foreclose. Because if you have an IP right, on the one hand, you incentivize the creation of stuff because it'll be monopolized, or because the creator will have a monopoly and will be able to exploit the IP right, or rather exploit his creation. On the other hand, follow-on creators won't be able to use whatever that creator has a monopoly on, and so you'll discourage follow-on innovation. And the question in the American conception of IP rights is always, do the costs or do the benefits outweigh the costs? And for software, there's real questions about that. This is all just one footnote in the paper, by the way, but there's real questions because software flourished for decades without patents. For decades, there were no software patents, so they're very rare, and software did just fine. Open source software is openly hostile to software patents, and it's also one of the most fertile areas of software innovation. So this idea that you can, I think there's probably real purchase to the idea that you need patent protection to have like a functioning like a drug industry. That is a whole area that is not an endorsement of how it works right now, but but I think you can make that argument for pharma. I really don't know if you can for software, but putting that aside, that's sort of like a ends justify the means kind of question, and that literature has been overwritten. But there's sort of this alternate reason that some people give for not allowing software to be patented. That's sort of a more metaphysical explanation, and it goes something like this: software is comprised of algorithms, and algorithms are just math, and you can't patent math. Therefore, you can't patent software. This struck me as also patently silly for the following reasons. And I think it's understandable that you might think that algorithms are just math because they are often described in mathematical terms. Both the actual description of the algorithm often uses, you'll see like a summation symbol or well, I don't know. You'll see stuff that you would sort of, if you were not a computer scientist, you'd look at that and go, ooh, oh no, math. And then the study of algorithms involves a lot of math because what you're studying is sort of how efficient they are, what their runtime is, which is to say, given a certain amount of input, do they run like linearly with that input, or quadratically, or polynomially, or exponentially, and so on? And the runtime efficiency of an algorithm is sort of one of its key aspects, and so you spend a lot of time in the study of algorithms doing that math, and that is math. But that doesn't mean that the underlying algorithm is math. And then the other reason sort of that you might naively or intuitively think that algorithms are math is because a lot of algorithms solve math problems. They solve problems like finding all the prime numbers from 1 to n, or finding the greatest common divisor. I mean, these are like some of the basic algorithms you learn in Intro to CS. But a lot of algorithms don't do that. A lot of algorithms are they have other ends, like PageRank, the algorithm that that vaulted Google to fame. I mean, it involves math because it involves adding up scores. But what it is an algorithm for ranking web pages based on relevance. There's algorithms for how to multitask programs in an operating system, how to pick the best chess move or poker move or StarCraft move, algorithms for memory management, all these things that aren't math. They're not solving math problems. They're solving other problems, and they're solving them using a set of instructions that can be described using math, but that doesn't follow that they are math. So I spend a good chunk of the paper sort of trying to refute this, and the reason it's such an important bad basis for excluding software is because the Supreme Court's very first software patent case actually used that reason. It basically said, not in so many words, but it's basically said algorithms are math, and you can't patent math, so you can't patent algorithms. And what everyone did after that was say, well, I guess we can't have algorithms in our patents, which isn't great, because what you do when you can't have algorithms is you just describe it in words, and your word description, it's not just easier to be too more general and too general with words. Sort of almost necessarily, you're describing what is a precise set of steps in imprecise language, which is doubly unfortunate because you actually have a fairly precise notation for describing the set of steps. It's what programmers use to communicate it to each other. It's this language called pseudocode, which sort of looks like roughly like the intersection of programming languages, if that makes sense. Like it's common operations that you'll see in any programming language, or if you're writing to a specific audience, you might import more like specialized terms from specialized like instructions or types of instructions from specific types of languages, like object-oriented or functional. But basically, pseudocode is something that's never going to run. You can't compile it, you can't run it, but you can look at it and figure out how to translate it into your language of choice. So that exists. That has existed as long as computers have existed. But because, and I think there may have been an inflection point where it was possible that was how algorithms would be claimed. But after Gottschalk, Johnson, which was in the 60s, that scared people away from putting pseudocode. Instead, they claimed the algorithm in words, and they ended up just claiming the results. And that's unfortunate because, and this is an idea that's been around in the eligibility literature for a long time, but actually algorithms would be pretty great. Like they would be a huge improvement over what we have now. They would be quite a bit more specific. They'd give you an actual implementation of the idea. If you had to claim an algorithm, you would actually have to have an algorithm. And I've read a lot of software patents where I look at the claim and I go, you have no idea how to do that. You just thought that it'd be cool if that were done. Yeah. So my proposal, and it really is a policy proposal, is that one, overrule whatever if Gottschalk is alive that still sort of says you can't patent algorithms. To the extent that that's still alive, overrule it, which is a bit of a heresy in sort of software patent skeptic circles, because Gottschalk is the great granddaddy of software patents not being eligible. But to the extent that it actually caused software patents to become more abstract, I think it's bad. That's one. And then two, having done that, require patentees to claim their software innovations using algorithms, using pseudocode. And this sort of just makes sense based on what like one of the basic trade-offs you get with a patent is supposedly, in theory, not really so much in fact, but in theory, you get disclosure of the invention in return for giving up to the inventor, a 20-year monopoly. And the way that a programmer would actually disclose his innovation to another programmer is using pseudocode. So it sort of makes no sense that that's how you would disclose it if you actually wanted to disclose it. But in a patent, which is supposed to require you to disclose it, you actually don't have to disclose it that way at all. So that's the proposal. And I sort of merged that with something that Mark Lumley proposed a long time ago, because what he proposed was that claims to bear results in software patents in general be read narrowly to cover only the means for those results in the what's called the written description, the sort of essay that precedes the claims. And this is in law. It's a section of patent code, but it's been interpreted very narrowly. And his proposal was, no, interpret it broadly. Like, look at a claim and say, that just describes the result, rather than just saying, does it use the word means for? Current doctrine is, if it says means for, then it falls under that section of the statute. If it doesn't, then it doesn't. So that's his proposal, and so I sort of tack onto that and say, okay, so patentees should have two options. You either you claim your algorithm in English and you get the Lenly treatment, and it's read very narrowly to only cover any algorithm that you disclose in the written description, or alternatively, you claim your algorithm in pseudocode and you get the Acharya treatment. You get a thick doctrine of equivalence. And so, you claim an algorithm X, and there's almost an innumerable number of ways to refactor the same algorithm to do the same thing, but do it in a slightly different way and accomplish the same result. And so, if you claim an algorithm in pseudocode, you would cover all of these equivalents. That's the basic proposal.
Well, yeah, so I thought this was just fascinating, right? And not a way of thinking about the kind of subject matter of patents that I had encountered before, although I'm not, not really my area, so I haven't read as broadly as you have, obviously. But I can't help but wonder, on one level, as you say, this does seem like a policy proposal in the sense that it's proposing a new or alternative or additional heuristic that courts ought to use in evaluating whether or not a particular patent claim is patent eligible. But I wonder if it also, as you kind of alluded to earlier, also has a kind of metaphysical or ontological quality to it. Do you think that this says anything about sort of what it means for something to be the kind of claim that can be patent eligible in a broader sense than just thinking about software, but kind of thinking about patentability writ large?
Yeah, I think this shorter paper grew out of what was trying to be a longer paper that was never going to get finished. That was going to be like a grand unified theory of patent eligibility. That's still languishing in my drafts folder. But Yeah, the reason that I mean, there's several ways to think about it, right? Like one way of thinking about it is, um, and this is one direction from which I approached the software patentability question was, does innovation happen in software? And the answer is absolutely yes. And if there's innovation happening, um, why shouldn't it be patentable? Now that could be quite question begging, if you don't define your terms, and if you do define your terms, you run into trouble because it's not clear where the line is between sort of innovation and discovery, which is why you have the other parts of that tripartite distinction, the laws of nature, natural phenomena, those the stuff that falls on the discovery side of that line, falls or could fall into those buckets. The other side of it is if you have an innovation, how concrete does it have to be before it's patentable? And my answer in software is it has to be concrete enough that you can uh, tell someone else the innovation and they wouldn't have to do any work to implement it. That's what pseudocode is. Like the sort of sine qua non of pseudocode is that it's something that you can give someone and they can implement it in their language of choice. How to take that more broadly, I'm not sure. It probably would be quite dependent on the field. It also probably doesn't matter all that much because most of the practical application of the abstract ideas doctrine now is in software patents, as I said earlier, and probably will only be more and more in software patents as more innovations become software based.
Well, so Athul, in closing, I couldn't help but feel like your paper was deeply informed by your own background as a software engineer. And I wonder if you had any reflections for law students and junior scholars about sort of thinking about sort of knowledge outside the law and how you can leverage that in relation to legal scholarship.
Yeah, so I came to the law because because I was a software engineer and I knew of software patent trolls that had been impacting open source software projects that I was a fan of or was contributing to or was trying to contribute to, and also because of some other sort of major legal battles that were heating up involving technology like net neutrality. And I think if you come to the law from some non-traditional field like that, I think it really pays dividends to not lose touch with what you know about the real world from your earlier studies, because I mean the law ultimately interacts with what people are doing that isn't the law. There's no law that's sort of just law for its own sake, or at least there shouldn't be. And computer scientists, software engineers, people outside the law, you'll often hear them say things like, "Why are so many of our lawmakers lawyers?" And I think as a lawyer, you sort of ask, well, of course they should be, right? Like they're the ones who know what laws look like. And I think it's really valuable to remember what it's like to be on the other side of that and have a sense of like why it was that you thought that the laws that lawyers were writing didn't make sense with the things you were doing in the real world, and that can be very valuable both in terms of practice and in terms of scholarship.
Well, Thank you so much, Athul. This is really a great conversation. Fascinating paper. I totally love it. I hope listeners will dive in, because even though this has been a long conversation, there's actually a lot more in the paper we weren't able even to cover. And I really appreciate it.
Thank you so much for having me on, Brian. I really appreciate the opportunity.
I'm more alive than ever before. I've been to my Commodore 64. My friends are knocking down my door to get into my Commodore 64.
It's mind-boggling. Commodore 64 lets you play hundreds more games than any video machine, plus draw, program, even do music.
I'm more alive than ever before, and my friends are